Sir, please unmute your mic, sir. Sir.
Yes, madam. Unmute ചെയ്തിട്ടുണ്ട്.
Yes, sir. So our second session today is on the topic, do climate change risks go beyond carbon footprint? And to talk about this topic, we are privileged to have Dr. Kochibaby Manuran S. Sir, Senior Manager, Retired Environment, BPCL Kochi Refinery as our speaker. Now I would like to invite Dr. Suraj Rajan C. for delivering the brief introduction about our speaker.
Yes, welcome you, sir. Dr. Kochibaby Manuran, over 30 years of industrial experience at BPCL Kochi Refinery and retired as Senior Manager Environment from BPCL KR and PhD in Technology from Cochin University Science and Technology and MS in Quality Management from Birla Institute of Science and Technology, Pilani. And he has certified lead auditor for ISO 9001, ISO 14001 and ISO 45001 and lead assessor for National Accreditation Board for Testing and Calibration Laboratories, NABL, and assessed over 200 laboratories across India for NABL accreditation and published several research papers in international academic journals. And he has authored 10 textbooks on topics such as petroleum refining, engineering chemistry, and sustainable engineering. Member of Board of Studies at various institutions including Maharajas College, Sacred Heart College, Mar Athanasius, Rajagiri, and Cochin University of Marine Science, and active faculty member at BPCL Kochi Refinery Training Center. And he has an invited speakers for numerous national and international seminars and UGC sponsored programs. And Dr. Manuran sir has made significant contributions to the field of environmental management and quality assurance, both in industry and academia. With all due respect, on behalf of Department of Chemical Engineering, we welcome you, sir, to this event and handing over you to sir.
Thanks, sir, for your nice introduction. Now I am moving to the topic. The topic assigned to me today is, do climate change risk goes beyond carbon footprint? As introduced, I am Dr. Kochibaby Manuran, basically from Kochi, and my experience lies with Bharat Petroleum Corporation Kochi Refinery, and the knowledge I gathered from the BF as being a member of the environment section of that great organization. Now I am moving to my topic. First, we will see what is climate science. Actually, climate science is natural effort of the humans to understand the natural forces that control our climate. It is actually a multidisciplinary field that involves the study of our atmosphere, oceans, and biosphere. So by undergoing this study of climate science, we are trying our best to have a control over the natural forces so that these climate change or climate variations we can bring under control. So what we can in this direction, we will see in this 1.5 hour session. Next point I have to bring before you is, what is actually climate change? If the previous winter is too cold, we will not call it as climate change. If the previous summer is too hot, we will not call it as climate change. They are all regarded as changes in weather patterns only. So what is actually climate change? Climate change is actually long-term shift in temperatures and weather patterns of the earth. By long term, how much it can be? It should be at least for a period of 10 years. Usually we take for a period of 30 years to understand whether actually climate change has happened or not. So 1 year, 2 year, 3 year, such changes are all coming under changes in weather patterns only. If the period under consideration is more than 10 years, then we can categorize those changes in weather patterns, long-term change or shift in temperatures and weather patterns as climate change. Now, the main culprit behind global warming, climate change, we consider as greenhouse gases. So what are the greenhouse gases in our atmosphere? Surely we are all behind carbon dioxide. It constitutes around 79.7% of the greenhouse category. That is why the whole our control is directed over to catch this carbon dioxide into our fold. So carbon dioxide is one of the major greenhouse gases in our consideration. The next one is methane. It constitutes about 11.1%, the next major greenhouse gas. The third one to be considered is nitrous oxide, N2O, that constitutes about 6.1%. Then the rest 3.1% is constituted by hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, nitrogen tetrafluoride, etc. So all those compounds together constitutes 3.1%. And altogether, this makes 100% of our greenhouse gas. So since about 80% of our greenhouse gases is carbon dioxide, that is why the whole our attention is going towards capture of this particular greenhouse gas, carbon dioxide. Next one is global warming potential, or in short, we will call it as GWP. What is actually global warming potential? Now you have found different greenhouse gases. Carbon dioxide is a greenhouse gas. Methane is a greenhouse gas. Nitrous oxide is a greenhouse gas. Then our fluorocarbons, chlorofluorocarbons are all greenhouse gases. Sulfur hexafluoride is a greenhouse gas. So this global warming potential is representing how much heat a particular greenhouse gas traps in the atmosphere compared to carbon dioxide. So its global warming potential is compared with carbon dioxide. And when compared with carbon dioxide, how much more heat it will trap, that is given as its global warming potential. So in this table, you can see different greenhouse gases, carbon dioxide derived from fossil fuels. And you can also see AR1, AR2, AR3, AR4, AR5, etc. and different years below. AR1 means assessment report first. AR2 means assessment report second. AR3 assessment report third. AR4 assessment report fourth. And assessment report fifth. That is what is being seen nowadays. And it has come from 2013. And if you can see, in all those assessment reports, carbon dioxide is getting the value of 1 only. Global warming potential, GWP of carbon dioxide is 1. Because all other greenhouse gases are getting compared with the potential of carbon dioxide. So how much more heat that particular greenhouse gas can trap compared to carbon dioxide. That is actually going to be given as global warming potential. And that is why in all the assessment reports, you can find that carbon dioxide is getting 1 because it is the basic medium or basic substance with which others are getting compared. Now, the next one is methane. And methane, you can see that is derived from fossil fuels. And there is also biogenic methane. We will see what is biogenic later. So whenever a fossil fuel is used for deriving energy, methane generation usually happens along with it in various processes. And in the first report, its global warming potential is given as 21. Second report also, its global warming potential is 21. But in the third report, it is still considered more dangerous. Its global warming potential is considered now in the third report as 23. In the fourth report, it increased up to 25. And in the fifth report, you can see that methane is considered, the global warming potential of methane is given 28. That means it is 28 times more harmful as a greenhouse gas, or it is having 28 times more global warming potential compared to carbon dioxide. Then the other methane is biogenic. We know we have to understand that even our cow generates methane because it eats this cellulosic material, and when bacteria degrades it, this methane is formed as a byproduct of it. In our waste, when our waste is dumped and decay, then also methane is produced. So they are all considered as biogenic methane, and its value is slightly lesser. You can see that in the first report, it is assessment report, it is only 1825. In the second report also, it is only 18.25. In the third report, its value increased to 20.25. In the fourth report, its value still increased to 22.25. And in the present assessment report, fifth assessment report, its value is 25.25. That means it is 25 times more harmful than carbon dioxide as a greenhouse gas, or its global warming potential or tendency to trap heat inside is 25.25 times more than our carbon dioxide. Similarly, you can see dinitrogen monoxide, N2O, that is a greenhouse gas. Its global warming potential is 290 in the first report. In the second report, its global warming potential is 310. In the third report, again decreased, its global warming potential is only 296. In the fourth report, its value increased still 298. And in the fifth report, the accepted value is 265. The others are hydrochlorofluorocarbon 141b. It is having in the first report only a global warming potential. In the first report, it is having a global warming potential of only 440. But in the third report, its value still increased to 700. In the fourth report, its value is 725, and now its value is given as 782. That means it is 782 times more harmful, or as a greenhouse gas, it is more dangerous by 782 times than our carbon dioxide. Then the next one is hydrofluorocarbon 134A. It is, you see, its value is 1,200 in the first report itself. Second report, it is 1,300. Third report also 1,300. In the fourth report, its value has come up to 1,430. And in the fifth report, its value is given as 1,300 times. So this hydrofluorocarbon is 1,300 times more harmful as a greenhouse gas when compared to carbon dioxide. Now we have HCFC, hydrochlorofluorocarbon 22. Its global warming potential is 1,500 in the first report. In the third report, its value is 1,700. In the fourth report, its value is 1,810. And now in the fifth report, its value is given as 1,760. That means this particular hydrochlorofluorocarbon is 1,760 times more harmful as a greenhouse gas when compared to carbon dioxide, or it can trap heat inside it 1,760 times more when compared to carbon dioxide. Then we have hydrochlorofluorocarbon 142b. Its global warming potential in the first report is 1,600. In the third report, it is 2,400. In the fourth report, it is 2,310. And now in the fifth report, its value is given as 1,980. That means it is 1,980 times more harmful as a greenhouse gas when compared to carbon dioxide. Now we have chlorofluorocarbon 11, CFCs. They are all banned nowadays. Chlorofluorocarbon, they are having the global warming potential 3,500 in the first report itself. In the third report, its value still increased to 4,600. In the fourth report, its value increased to 4,750. And in the fifth report, now its value is lying at 4,660. That means it is 4,660 times more harmful as a greenhouse gas compared to carbon dioxide, or it can, compared to carbon dioxide, it can trap 4,660 times more heat compared to carbon dioxide. Then coming to CFC12, it is still more dangerous. It's in the first report itself, its global warming potential is 7,300. In the third report, its global warming potential is 10,600. In the fourth report, its global warming potential is 10,900. And now in the fifth report, its value is given as 10,200. It is 10,200 times more harmful as a greenhouse gas when compared to carbon dioxide, or it can trap heat inside 10,200 times more when compared to carbon dioxide. And now we are coming to the worst one, sulfur hexafluoride. Its global warming potential is 23,900 in the second report. In the third report, its value is slightly decreased to 22,200. In the fourth report, then also increased to 22,800. And now in the fifth report, its value is given as 23,500. That means sulfur hexafluoride is the worst. When we see it as a greenhouse gas, it can trap heat 23,500 times more when compared to our carbon dioxide, or as a greenhouse gas, it is 23,500 times more harmful when compared to carbon dioxide. So that is all with the global warming potential. So just to have on having a look on the global warming potential, we can understand how much dangerous these gases are when compared to carbon dioxide. And this carbon dioxide is the poor chap among the greenhouse gases. But why we are all behind carbon dioxide? Because it is being emitted in huge quantities. So almost 80% of the population is contributed by carbon dioxide. That is why all our efforts go to have a control over these carbon dioxide emissions. Now we have to see what is actually global warming. What is actually global warming? Sun is the source of all our energy. And where the radiations coming from the sun, it is absorbed by the atmosphere, earth, everybody. And the earth heats up, and the increased heat energy, this earth will radiate out in the form of infrared radiations. Infrared radiations are nothing but heat radiations. But these greenhouse gases, whether it be carbon dioxide, whether it be methane, whether it be nitrogen oxides, whether it be these hydrochlorofluorocarbons or sulfur hexafluoride, whatever it be, all these greenhouse gases forms a layer over the Earth's atmosphere. And these greenhouse gases, instead of allowing the reflected light, reflected heat in the form of infrared radiations from the Earth to escape into the outer space, they prevent as a blanket covering these infrared radiations from going out into the outer space. Instead, this layer of greenhouse gases re-emit or reflect back these infrared radiations, or nothing, or what we can call as heat radiations, back into the surface of the Earth. So those radiations which would have escaped out, that is prevented by these greenhouse gases presence. That is why they are returning it back, or reflecting it back these infrared radiations into the atmosphere of the Earth itself. That is why the surface temperature or the atmosphere temperature increases, and that is what we call as global warming. If you want to know physically what is global warming, just keep your car under sun over 1 or 2 hours in the under the hot sun. Then you are walking through then you are walking and trying to enter the car. Then you can see that you cannot hold the steering wheel. You cannot sit on the seat. When you sit inside, that suffocating that feel you get. So this is actually the physical demonstration of global warming. When these returned radiations are here, the water vapor, this water vapor is also a greenhouse gas. It can also contribute to global warming. So all these together gives us a boiling effect. That is what is actually called the physical realization of this global warming. But these greenhouse gases are good also in one way, because we get a reliable, livable temperature in the earth because of these greenhouse gases only. If no greenhouse gases would have been, then the surface temperature of the or the atmospheric temperature would have been reduced to minus 18 degrees centigrade. We could not live here. So these greenhouse gases are actually required, but at a controlled level, so that we can get a livable temperature. But what is happening now? Their concentration is going without any control, is going up without any control. So the trapping of heat inside is becoming more and more. So the surface temperature, the average surface temperature of the atmosphere, and the average temperature of the atmosphere is going up. And that is why we now focus on these greenhouse gases to have a control. Now, next to my question is, what is the global average temperature of the Earth? Anybody have an answer? If anybody is involved in crude trading, because this crude purchase, sales, etc., are international mechanisms. So the density of crude is always expressed at 15 degrees centigrade, or within brackets, we can say that in Fahrenheit it is nearly 60 degree Fahrenheit. So being in a petroleum industry, I many times thought why they are not reporting the density at our room temperature 25 degrees centigrade. Instead, they are reporting the density of this crude oil and all petroleum products also. That density is reported at 15 degrees centigrade only. Not at our room temperature 25 degrees centigrade. When I searched behind, then the answer I got is that the global average temperature accepted is 15 degrees centigrade. So that is why the global average temperature is 15 degrees centigrade. And so even a 1 degree rise in temperature can give so many changes in effects. And this carbon dioxide is the culprit, or is the main contributor, or 80% of the greenhouse gases, which can change this global average temperature. So the average temperature of the earth accepted is nothing but plus 15 degrees centigrade, or in Fahrenheit it can be 59 degree point something Fahrenheit. Now, whenever we come to climate change, global warming, etc., we take the year 1800 as the base year. What is the significance of this year, or what is the importance of this particular year? Earlier, only natural way of doing only happening. From 1800 onwards only, that industrial revolution has come up. We started major industries started coming up, and those times coal is being used as fuel, oil being started as using as fuel. So all these contributions, carbon dioxide emissions actually started from from the year 1800. So that 1800, before the Industrial Revolution, that 1800 is taken as the base year to have a control of our carbon dioxide. And anybody having an idea what is the concentration of carbon dioxide at this period or during the ages 1800 years? In the atmosphere, the carbon dioxide concentration was only 278 ppm. 278 ppm. That means 0.027 percentage. Only that much carbon dioxide was present in our atmosphere as a greenhouse gas, and we got a livable temperature, good temperature, and we are happily living. But thereafter, usage of coal increased, usage of oil increased, all these petroleum refineries has come up, and all these petroleum products, petrol, diesel, LPG, everything became used on a wide scale. So all these compounds are carbon-based compounds. So this burning is nothing but oxidation. So if any hydrocarbon, these are all called hydrocarbon fuels, hydrogen and carbon content fuels. So when these fuels are burned, what will happen? Hydrogen will get oxidized to water, water vapor will come up. Carbon will get oxidized to carbon dioxide. So that carbon dioxide accumulation in the atmosphere started. So the 1800 is taken as the base year from which our atmosphere started with accumulation of carbon dioxide. Up to 1800, no major activities, industrial activities were there. So the carbon dioxide concentration was on a medium scale, that is the 278 ppm. And so no global warming and all. Now, before going further, we should know what is the concentration of our atmosphere, different gases in our atmosphere. Our atmosphere, the major component is, the major gas present in our atmosphere is nitrogen. It constitutes about 78%. What is, have you ever thought what is the role of this nitrogen in our atmosphere? Of course, nitrogen is a nutrient for our plants that is getting transformed into different forms for food manufacture, plant, so like that. But this nitrogen, if otherwise, if any burning happens, it would have been much vigorous, or we can say that it would have been much violent. Actually, this nitrogen is an inert gas that is helping us to have controlled combustion. So being an inert gas. So nitrogen, nitrogen is present in our atmosphere to an extent of 78%. The next major component of our atmosphere is oxygen, 21%. We need oxygen for our respiration, and carbon dioxide we are giving out. That carbon dioxide is taken up by plants and all for carbohydrate manufacture. And the carbon dioxide present in the next major gas present in our atmosphere is argon. That is also an inert gas. Its concentration is about 0.96%. And what can be the carbon dioxide concentration now in our atmosphere? Now, you know that in 1800, before the Industrial Revolution, the carbon dioxide concentration in our atmosphere was only 278 ppm, or if we say it in percentage, it is only 0.027%. Now you can see that its concentration is given as 0.04%. So it increased from 278 level, it increased to 0.04%. If you convert it into ppm, what will be the value? It will be 400 and more. Actually, our atmosphere now contains carbon dioxide to a level of 422 ppm. From 278 ppm, over the years, by the use of these fossil fuels, coal, petrol, diesel, or these petroleum products, our concentration in the atmosphere is increased. The carbon dioxide concentration is increased to 422 ppm. So see how much increase has happened over the years why the use of these fossil fuels. That is why everybody are behind this carbon dioxide. We should have a control over the emissions of carbon dioxide. Otherwise, all the things will go out of our control. This climate change, we cannot do anything. Global warming, we cannot have any control. That is why international conventions are held to have a control over these greenhouse gases, especially carbon dioxide. Now, coming to the different layers of the atmosphere. What are the different layers of the atmosphere? The first layer is troposphere, where we have all our activities. It extends up to a height of 12 kilometers. Then just above the troposphere, we can see the stratosphere. It extends up to a height of 50 kilometers. So 12 to 50 kilometers, that is the stratosphere region. And between the troposphere and stratosphere, you can see a white line that is actually representing the ozone layer. Where is the ozone layer lying? It is approximately at a height of 25 kilometers from the Earth. Then above the stratosphere, you can see mesosphere, which extends from 50 kilometers to 80 kilometers, the mesosphere region. Then from 80 to 700 kilometers, you can see the thermosphere region. And beyond the thermosphere, we have the exosphere. So coming to the different layers of the atmosphere, we can say that there are 5 different layers: troposphere, extending up to a height of 12 kilometers, stratosphere, extending from 12 to 15 kilometers, mesosphere, extending from 50 to 80 kilometers, thermosphere, extending from 80 to 700 kilometers, and beyond 700, we have the exosphere. And all our activities are happening in this troposphere region of our atmosphere. Now, we are now discussing about climate change. And you might have read all the newspapers this previous week. A big fire, a catastrophic wildfire is stunning the world. And this catastrophic wildfire is happening nowhere else. It is happening in Los Angeles. About 40,000 acres are under fire. The most developed country, USA, it is able to extinguish only 10 to 15% of the fire. The rest is still burning. And the wind, Santa Ana, that is making it still worse by its fury. And you can see that roads are choked by abandoned vehicles. Even the fire tenders cannot move. The whole region is devoid of any water. So such things can happen anywhere else also, if we are not having a control over the emissions of this carbon dioxide. So now we can go to that this one. That video will
எனக்கு என்னமோ உலகம் அழிய போகுதுன்னு தான் தோணுது. இந்த மாதிரி ஒரு தீ விபத்தை நான் இதுவரை பார்த்தது இல்லை, இது கேள்விப்பட்டதும் இல்லை. ஏன்னா கட்டடங்கள்லாம் அப்படி அப்படியே தீப்பிடிச்சு எரியுது. இது வந்து காட்டுத்தீ பரவுனது தானான்னு எனக்கு தெரியல. அமெரிக்காவில் லாஸ் ஏஞ்சல்ஸ் கம்ப்ளீட்டாக காலி, கலிஃபோர்னியா அப்படியே அழிஞ்சிருச்சு. அப்படியே எப்படி இதெல்லாம் மொத்த பூமியுமே நெருப்பாகவே இருக்குதாங்க. இப்போது 4-5 நாளாக எரிஞ்சிட்டு இருக்கு. இன்னைக்கு வரை அந்த நியூஸில் அது போட்டுட்டு தான் இருக்கான். கட்டடங்கள்லாம் எரிஞ்சு புகை மண்டி ஊரில் யாருமே இல்லை, எல்லாருமே வெளியே ஓடிட்டான். இந்த மாதிரி இருந்துச்சு 4 நாளைக்கு முன்னாடி. ஆனால் இதே இடம் இப்போ எப்படி இருக்குன்னு உங்களுக்கு தெரியுமா? அதில் போட்டிருக்கான் பாருங்க. எரிஞ்ச கட்டடங்கள்லாம் எனக்கு பார்த்தாலே கல்லெல்லாம் எரிஞ்சு விடுது. கட்டடங்கள்லாம் பிடிச்சி எரியுது. ஒரு மெக்டானல்ட்ஸ் எப்படி எரியுது பாருங்க, பச்சை மரம் பிடிச்சி எரியுது. எனக்கு என்னன்னா, அவ்வளோதானே நம்ம சேர்த்து வச்சது, எல்லாருக்கும் இப்போ உதவி பண்ணலையா, குடும்ப சண்டை, அந்த சண்டை இந்த சண்டைன்னு அந்த மாதிரி நான் தத்துவம் சொல்ல வரல. எல்லாமே வேஸ்ட்டாக போச்சே, நம்மளுடைய சிந்தனைகள் எல்லாம் வேஸ்ட், சேர்த்து வச்சதெல்லாம் வேஸ்ட். ஒரு பூமி ஒரு பக்கம் தீப்பிடிச்சி எரிஞ்சு அசத்தும் போது யார் அதை தடுக்க முடியும்? யாரால என்ன செய்ய முடியும்? நின்றுக்கிட்டு இருக்க பச்சை மரத்துலேருந்து அப்பார்ட்மெண்ட் பில்டிங் வேற, எல்லாமே எரியுது. கடற்கரையெல்லாம் அதுக்கு பக்கத்தில் இருந்ததெல்லாம் எங்கேருந்து வந்துச்சு இந்த நெருப்புன்றான். ஒருத்தர் சொல்கிறான் மேலேருந்து கொட்டுச்சுங்கிறான். இது வந்து கார் உருகிட்டு போன இது அலுமினியம் உருகி ஓடி இருக்கு. எல்லா பில்டிங்குமே எரிஞ்சு போச்சு. இன்னும் நடக்குது. எனக்கு என்னமோ உலகம் அழிய போகுதுன்னு தான் தோணுது. இந்த மாதிரி ஒரு தீ விபத்தை நான் இதுவரை பார்த்தது இல்லை, இது கேள்விப்பட்டதும் இல்லை. என்ன கட்டடங்கள்லாம் அப்படி அப்படி தீப்பிடிச்சு எரியுது. இது வந்து காட்டுத்தீ பரவுனதுதானான்னு எனக்கு தெரியல. அமெரிக்கா.
So that is about the video. So if such fires are happening anywhere, nobody can do anything, or whatever facilities we have, that will become mere mute spectators or totally helpless over such situations. So carbon dioxide is our problem maker. We all want to have a control over this carbon dioxide. That is why we have the mechanism called carbon footprint. So it is a valuable tool. If your carbon footprint is under control, then these emissions will be under control. So all these mishaps we can avoid to some extent. So first of all, we should know what is carbon footprint. Carbon footprint is the total amount of greenhouse gases that will be emitted and expressed in terms of carbon dioxide equivalents. Now you know that there are different greenhouse gases. Methane is there, nitrous oxide is there, fluorocarbons are there, sulfur hexafluoride is there, nitrogen tetrafluoride is there. All these different gases, even though they are different in origin, their quantity is expressed in equivalent tons of carbon dioxide. So whether it is methane or nitrogen dioxide or this fluorocarbons, all their quantities are expressed in metric tons of carbon dioxide equivalent. Then it can be called as carbon footprint. It is a valuable tool to know the carbon dioxide emissions from that particular activity or organization or individual. Then our main aim is to control our global average temperature. Our global average temperature is rising, no doubt. But we want to limit the rising of this global average temperature to a level of 1.5 degrees centigrade, and no way it should be allowed to go beyond 2 degrees centigrade. That is our main focus. So to have a control over this carbon dioxide emission, we should calculate carbon footprint. And this carbon footprint calculations should help us to maintain the global average temperature from surpassing the 1.5 degrees centigrade rise level. It should not rise beyond this 1.5 degrees centigrade. For that, we have to calculate carbon footprint at multiple levels. It can be at the national level, it can be at the organizational level, it can be at the individual level. All these things are to be monitored so that this carbon dioxide emission will be under control. And what are the different types of carbon footprint? Individual level. As an individual, we are also emitting carbon dioxide. We move to office, whether it be in bus or car or any other medium of mode of transportation. So our moving that is releasing carbon dioxide into the atmosphere. When we prepare our food, we are burning LPG or natural gas, whatever it be. So that is also a carbon compound that is also contributing carbon dioxide. We are using water, it is being pumped from somewhere else. We are also pumping it to the overhead tank. So electricity is consumed for the process. So that electricity generation involves carbon dioxide emission. So a part of the carbon dioxide emission that way we are also contributing. Then we wear clothes. These clothes is manufactured somewhere else. During that cloth manufacture, carbon dioxide emission would have happened. So all our activities has to be considered. What all activities we do, All our activities has to be listed out, and what are the contributions from those activities that we have to list out and add together to get our carbon footprint. Then it becomes our individual carbon footprint. Then carbon footprint can be calculated for a product also. From raw material extraction to its design as product to its use as product, then it is disposed as a waste, or it is subjected to recycling activity. Under all these stages, what all carbon dioxide are being emitted, that is, they are all added together to find the carbon footprint of that particular product. Now coming to our organization, whether it be a manufacturing organization, then steam generation is happening. For just generating steam, we are burning fuel, so carbon dioxide is emitted. So per ton, what is the carbon dioxide emission that happening for the steam generation? In a manufacturing process, we are using electricity. So how much electricity is being consumed by that particular company for manufacturing activities? Then movement of vehicles happens inside the organization. So how much fuel is being burned? Then workforce movement. So several activities are happening inside an organization or company. So all those together we have to add up to get the carbon footprint of that particular organization or company. And that we have to express in terms of metric tons of carbon dioxide equivalent to get the carbon footprint. And it can be also calculated for a country. Our country, what is the carbon dioxide emission? What all happenings are there in the taking place inside the country? All that organizational contributions, all that manufacturing stations contributions, all individual contributions, all those together we have to add up and express in metric terms of carbon dioxide equivalent to get carbon footprint. So this carbon footprint is an indication of our real-time emissions happening from all our activities, whether it be in an individual level or product level or organization level or country level. All that can give you a clear picture of our emission criteria. And our choice should be what can be the different ways to minimize this carbon dioxide emission or to minimize our carbon footprint. So when you design products, when you design organizations, or even at our individual, that thought process has to happen to reduce or to find ways to reduce carbon footprint. Now you can see the various factors that can contribute to this carbon footprint. One is direct emissions, carbon dioxide direct emissions by fuel burning. The next one is electricity consumption. The next one is transport activities. Then carbon dioxide offsets, generation and consumption will be happening, so that you can deduct from those things. Then there can be waste disposal activities. Then there can be recycling activities. Gas would have been used. Different types of fuel would be in use. All these contributions you have to add together to find the carbon footprint. That is why it is given just our foot picture, it is given. So this carbon footprint is an important tool to know our emission or to control our carbon dioxide emissions. And the major source we know fossil fuel burning is the major source for it. And average carbon footprint we have to calculate in country level. Average carbon footprint is calculated. It is closer to 4 tons average carbon footprint, and actually it has to be calculated at multiple levels, as including national level, organizational level, and individual level, so that for everywhere we can have a control to find ways to minimize carbon footprint. Now you can see that the average carbon footprint on a global scale is closer to 4 tons. But In the case of United States, the average carbon footprint is coming to 16 tons. That is why all international summits we propose the rich countries has to reduce their carbon footprint, so that only we can have a control over our these carbon dioxide emissions. We can have a control over this climate change. We can have a control over this global warming of all activities. Now we will see how we will calculate a carbon footprint. There are two mechanisms. One is life cycle assessment. Life cycle assessment. What is life cycle? Cradle to grave approach. From the moment it is generated to the moment it dies and goes out. That what are the different pathways it has to go? What are the carbon dioxide emissions in its journey can happen? All these things you have to sum up and calculate that carbon footprint. That is what is called a life cycle assessment or cradle to grave approach. But to find the different processes, different stages, this particular thing goes during its life cycle. That is numerous. So we have to find out each and everything, and we have to add up, sum up all these things to find the carbon footprint. That is why this life cycle assessment process is always told a tedious process. It takes days to calculate. And so when it on a large scale, this life cycle assessment is not a good thing for calculation of carbon footprint. So what we follow nowadays is input-output analysis to determine the carbon footprint. What are the inputs? What are the outputs? That way we calculate all those that carbon dioxide contributions, and we calculate carbon dioxide. Then from each activity, how much kilograms of carbon dioxide are spent on products. And this gives a faster way to calculate carbon footprint. And this enables to handle large amounts of data also. So input-output analysis is considered as a more convenient tool for determining this carbon footprint of our products or activities. And when we go to calculation of a carbon footprint, we have to consider three categories. First is scope 1 emissions. Scope 1 emission is nothing but direct emissions. Directly it is emitted as carbon dioxide from that particular activity. Suppose the vehicle is running 600 kilometers. It is burning out 20 liters of petrol. So this petrol is a carbon compound. During burning it gets oxidized to carbon dioxide and going out. So direct emissions. That fuel spent for that particular process is directly contributing to carbon dioxide emissions. So that we will take under direct emissions. Then to run the machinery, we need electricity or maybe steam from some other source. So that electricity is produced either by coal burning or by diesel burning, like that. Generators has to work. So there is a carbon dioxide contribution for that electricity generation also. Or steam is generated by burning fuel oil. So there is a carbon dioxide emission for the generation. 1 ton of steam generation, this much carbon dioxide emission will take place from that region. So they are all coming under indirect emissions or scope 2 emissions. That is the electricity what we use being produced in some other station. That emissions are happening there only, but you are responsible for that part of that consumed quantity of that particular electricity. That contribution is because of you. And so you are responsible for that much carbon dioxide emission happening in the generating station of that electricity. So that is coming under scope 2 emissions. Then indirect emissions. You are giving your product out, selling out your product. Your distributor is carrying it to far out for regions. So the distributor is burning fuel. So for selling that products, that carbon dioxide emission is happening or not at your end, but at the other end, the supplier end or distributor end. So that is also partly, you are also partly responsible for that activity. So how much emissions are happening that way, that comes under scope 3 emissions. So you have to calculate three factors. Scope 1 emissions, or what we call direct emissions. Scope 2 emissions, or what we call indirect emissions, like electricity usage. Then scope 3 emissions, that is also representing indirect emissions, but it is by your suppliers or distributors like that, because of their fuel usage. So all these things you have to add up, then only you can really find what is your carbon footprint. So scope 1, scope 2, scope 3 emissions, separate you have to calculate and sum up. Then you will get the carbon footprint of that particular activity or of that particular product. Now, I am giving a particular example of this carbon footprint calculation. You can see that during the past year, if you use 10 gallons of fuel per hour and you ran your engine for 2,204 total hours, your calculation would be actually hours into that 10 gallons of fuel per hour. So 10 into 24, that is the total used fuel is 2040. And each the fuel here you have used this marine diesel. This marine diesel can produce 21.24 pounds of carbon dioxide per each gallon, that we have found by analysis. So that is called emission factor. So 2040 is your total consumption. This 2040, your total consumption, you have to multiply by the amount of carbon dioxide that will be generated per gallon. That is 2040 into 21.24. So it will come to about 43,329 pounds of carbon dioxide. If you convert it into US tons, then it will become equivalent to 21.7 US tons. So this way we can calculate our carbon footprint. In India, we are representing in liters. So if you are using petrol for your vehicle movement, the emission factor is 2.296. 2.296 kilogram of carbon dioxide per each liter of petrol consumed by you. So if you are using 100 liters of petrol for your particular activity, 100 into 2.296, that will be your total emissions. Then diesel contains, that petrol contains 9 to 12 carbons only, but diesel can contain up to 20 carbons. So the carbon dioxide emission from diesel will be still more. So in the case of diesel, if you have to calculate the carbon footprint, suppose you are using again 100 liters of diesel for that particular activity or for that particular movement, then that 100 into 2.653, its factor is something more. Earlier petrol is 2.296 only, here it is 2.653. So 100 into 2.653 kilograms per liter, that will be your carbon dioxide emission. And for your process, you need electricity also. Suppose you use 100 units of electricity or 100 kilowatt hour of electricity for this particular activity, then that units should be multiplied by electricity generation factor. Emission factor is that, and it is 0.82 kilogram of carbon dioxide per kilowatt hour in our country. So how much electricity is consumed? Into 0.82 kilogram carbon dioxide per kilowatt hour. That will be your emissions. So in each case, depending upon the fuel used, you have to consider what is the total consumption of your fuel, and you have to take the respective emission factor to find out the carbon footprint. It can be in the form of electricity, it can be in the form of steam, it can be in the form of petrol, diesel, or ATF, aviation turbine fuel, that is plain fuel. And or it can be in the case of fuel oil, that is the ships are mainly running on fuel oil, furnace oil. So the corresponding factors you have to take and you have to multiply to get the actual emissions of the carbon footprint. Now it is given in a nutshell. Petrol 1 liter gives rise to 2.3 kilogram of carbon dioxide. Gasoline and petrol are same things, but differently named in some countries. Gasoline also 2.3 kilogram. Diesel contains more carbon, so its emissions comes to about, if you round out, you will get it as 2.7 kilogram. And oil, heating oil is nothing but a furnace oil or fuel oil, we will call. 1 liter of it will contribute about 3 kilogram because it will contain still more carbon atoms than diesel. If diesel contains 20 carbon atoms, fuel oil can contain up to 30 carbon atoms. So its carbon dioxide contribution will be still more. That is why its emission factor is coming to 3 kilogram per unit. And kerosene 1 liter, if you are using, kerosene contains about 12 to 15 carbon atoms. And its emission factor is 2.48 kilogram. So depending upon the fuel used, you have to take the corresponding multiplication factor and you have to find out what is the carbon dioxide emission happened, or to find the carbon footprint. Then, while finding the carbon footprint, there can be actual process and additional products. Suppose you distill that crude oil and get petrol, diesel, naphtha, LPG, like that, etc. In order to purify these compounds, we have to still go for additional processes like water cleaning or steam reforming, like that. Several additional sub processes we have to do to get those products in a pure manner or in a saleable manner. So whatever electricity is spent for those activities, or whatever steam is utilized for those activities, that also you have to consider for finding the carbon footprint. That is why here there are two columns, that actual process, how much carbon dioxide emission has happened. It has calculated to 5060.4. And in the additional process, like a cleaning or purification or impurity removal, or that color improvement or order improvement, several processes that these products has to undergo. For that additional process, how much carbon fuel or steam or electricity is utilized, they also make a contribution for this carbon dioxide emission or towards this carbon footprint. And here it is calculated to be, if the actual process has given rise to 5060.4 tons of carbon dioxide, this additional process also contributes to about 2.4 tons of carbon dioxide. So together is the carbon dioxide emission or carbon footprint. So you have to divide by the tons of fat that amount of fat you have produced. You have to divide it by the tons of fat produced. Then you will get, it is 1.3 is the carbon footprint of this particular product. So how much tons of product you got? That can be in the denominator, and the numerator should be the total actual process and additional process, how much carbon dioxide emission has happened in metric tons. That has to be in the numerator. So the carbon footprint is tons of carbon dioxide equivalent per tons of fat. That is given as 1.3. Now, what is alarming us? The global average temperature. We want to control the global average temperature from rising beyond 1.5 degrees centigrade. Never the global average temperature should be allowed to go beyond 2 degrees centigrade. That is our ultimate aim. For that, we should have a control over this carbon dioxide emission. And when we trace back the carbon dioxide additions to our atmosphere, lot of realities comes into our picture. One is the first reality we see, that there is a linear change up to 1950. What is linear? Decade after decade, the change is same. Then only we can get a linear graph. You are making a graph by plotting some values on x-axis and some values on y-axis, and you are getting a linear straight line graph. If that straight line graph slope has to be same, this increase should be same on each and every period. So up to 1950, nothing was wrong. carbon dioxide additions were there, but it was in a linear fashion. That means every 10 years, the additions was happening in a normal way. So, no climate change, no global warming, no suffocate that all these problems what we see nowadays. That is why what we see up to the year 1950. And you can see that up to the year 1950, per decade, the rise in temperature was only global average temperature rise was only 0.11 degrees centigrade, 0.11 degrees centigrade per each decade. Since it is linear, no trouble, no harm, no worry. But after 1970, our that facilities increased. Now we need air conditioners. Now we need fridges, refrigerators. Now we need gas stoves. Now we need that microwave. Now all our facilities happened big manufacturing stations. So all our necessities increased. So we can see that from the year 1970 to 2010, the increase in global average temperature from 0.11, it rose to 0.18 degrees centigrade. 0.11 to 0.18 degree centigrade. And the contributing factors may be industrialization, population explosion, and globalization. So all those things would have contributed for the same. Anyway, what we see is that up to 1950 there is a linear growth only, 0.11 per each decade. But during this 1970 to 2010, that 40-year period, we find that the growth is that is changed 0.18 each degree centigrade in each decade. And if you trace back, you can see that 19 of the hottest years on record occurred in the last 20 years. In this last 20 years, this 19 of the hottest years occurred. And from 2014, our observation still different. Instead of 0.11 up to 1950s, instead of 0.18 up to 2010, now we see that per each decade, 0.26 degrees centigrade change in temperature happens. And when we compare to the pre-industrial levels, 1800 a year, now the global average temperature is 1.3 degrees centigrade already increased. Our aim is to control at a level of 1.5 degrees centigrade, global average temperature increase. But now itself we find that from the level from what temperature global average temperature was there in 1800, from that level we have already reached 1.3 degrees centigrade higher temperature level, or the globe became warm by 1.3 degrees centigrade more by this year. And when we turn back to the last year, that year witnessed 1.6 degrees centigrade increase in global average temperature. If we are continuing in this situation, if nothing is getting controlled, if this uncontrolled fashion of carbon dioxide emissions are happening in our atmosphere, then no doubt we will reach the catastrophic level. Catastrophic level is 2 degrees centigrade. 1.5 is our aim to limit. But even that 2 degrees centigrade rise, we will have to see, or we will have to suffer, we will have to witness within 20 years. And by 2100, the global average temperature can rise if this fashion it is happening in 2100. That is why we all are behind this carbon dioxide control or carbon footprint calculation to have a control, and international summits are held every year to get this carbon dioxide addition under control, or to have a control over this global warming and climate change. Then when you hear me, you may doubt, why 1 degree rise in temperature you are making so much cry? merely 1 degree centigrade, 15 degrees centigrade, or that 1 degree rise in temperature in global average temperature. What should be the, why so much cry should happen? Or why this much loud noise is making by all over the world for this slight 1 degree rise in temperature? You may think so. If you want to realize the real situation, you think about the size of the earth and how much energy retention this mere 1 degree can make. It can make energy retention of 5 into 10 raised to 18. You just see the figure, 5 into 10 raised to 18 kilojoules. So what is the, can you imagine that figure, 10 raised to 18? That is 5 into 10 raised to 18 kilojoules of energy will be retained in this globe or planet by this mere 1 degree rise in temperature. And this much energy is equal to the energy present in our entire world's non-oil resources. Whatever oil resources we have all over the world, that oil contribution is equal to this 5 into 10 raised to 18 kilojoules. That is why this is a threatening figure. Even this 1 degree centigrade rise in temperature can do lot of harm to us or to our atmosphere or to our living conditions. And if this much energy is trapped inside, what can happen? More water will evaporate from our oceans. Then what will happen? Cloud burst, what we feel, what we see now, cloud burst or severe rainfalls. If the oceans are heated up by this much energy, what will happen? Sea level will rise. So all the low-lying areas will be flooded. And this much energy, if it goes to the, actually the sea and land temperature gives rise to winds. So if this much energy goes into the wind, then it can become hurricanes. That energy content of these hurricanes, strong winds will come, that all mishaps will happen. Then if this much energy is trapped inside the planet, severe droughts can happen. Water scarcity can be a reality. Severe fires can happen. Ocean acidification, flooding, melting of polar ice, catastrophic storms, declining biodiversity, heat waves, and even disease patterns also may change. That is why we are afraid of this 1 degree centigrade rise in global average temperature, because the energy content of it becomes equal to about 5 into 10 raised to 18 kilojoules. That is a huge figure which we can never imagine. Then you just to see how much oil is being consumed in our world. 15 billion metric tons of fossil fuel is consumed last year. So see the figure of that oil, coal, or fossil fuel consumption. All these are heavy carbon products. Carbon numbers range from 1 to 40, like that. So how much carbon dioxide emissions we are adding to our atmosphere each and every year? That figure, this 15 billion metric tons of fossil fuels are burned last year only. So how much last year itself this carbon dioxide addition would have? And the largest producers of fossil fuel carbon dioxide emissions worldwide. If you can see, China is 27.21%, USA 14.58%, India 6.82%, Russia 4.68%, Japan 3.33%. See the figures. So coal, oil, natural gas, everything is getting burned in an uncontrolled fashion, adding to adding carbon dioxide tons and tons to our atmosphere every year. And you see the global carbon budget. The global carbon budget is what do you mean by carbon budget? It is the total amount of carbon dioxide we can emit if we want a decent chance of limiting global warming to less than 2 degrees centigrade. It is estimated to be about 3,000 billion tons since the industrial revolution. And annual emissions of us comes to about 41 billion tons. Now you come to the real figures. Now we can emit to have this 1.5 degrees centigrade level. We can emit. Remaining is only 235 billion tons of carbon dioxide, which we can add to the global carbon budget. Now per year we emit about 41 billion tons of carbon dioxide per year. If this is continued, then within 5 years, we will reach the level of 1.5 degrees centigrade. So the situation is going, the window is closing very fast. Only 5 years left before us to reach the level of 1.5 degrees centigrade, the alarming level, where we have to have a control over this global warming. So to meet this 1.5 degrees centigrade, the rich countries need to cut their emissions at least by 45% compared to our 2010 levels. But many are still reluctant to agree to that. That is why still things are getting dragged again. The world needs to reach net zero emissions by 2050. But if consensus has to happen, then only we can ensure that our world will reach net zero emissions by 2050. And my topic was climate change risk beyond carbon footprint. Why I named that way, beyond carbon footprint. You see, now our total focus is going only this carbon dioxide emission, or what we call carbon footprint. That is what is called a tunnel vision. We have several things to view, but we look only a narrow portion. That's what we call tunnel vision. Our focus is too narrow. Our focus is not wide enough to see all the other contributing factors. We are only after carbon footprint. That is what is called carbon tunnel vision. No focus on other factors of sustainability. We have to sustain in this world. We have to live in this world happily. For that, we have to see, or we have to make a control over other contributing factors also. Ecotoxicity, ecosystem degradation, biodiversity loss, eutrophication, water crisis, resource scarcity, human right abuses, health impacts, air pollution. All these factors are going unattended. We are going only after this carbon dioxide emission, carbon footprint, etc. Our focus is too narrow. We need to broaden the scope to ensure a sustainable future. We need to focus environmental, social, and governance impacts. And what we need is not a single-minded concentration. What we need is an integrated solution that can address both the direct and indirect impacts of our climate change. We should not see the direct impacts only. We should see all the impacts, the direct as well as the indirect impacts of this climate change. So what is needed? What will be the impact if higher rainfall is happening because of climate change? We should address those factors. What will happen if accelerated deforestation is happening because of this climate change? What will happen if these forests are not livable for the animals? The animals are coming out to domestic stations. Then what will be the impact of those activities? Then what are the resettlement? Those people has to be shifted to some other place because the conditions of living is not there. So the resettlement costs, what will be the nature of the resettlement costs? The dams, whether they will sustain this much flood, this much rainfall, can they sustain? So structural stability of dams we have to consider. What will be the impact of if a heavy drought is coming? What will be the impact of less rainfall on a real water scarce region? What will be the impact of forest fires if it is happening? What will be the impact of the biodiversity changes? All these indirect impacts also should be taken into consideration, not the carbon footprint only. No, we should not make a tunnel vision only. We should take into account all the contributing factors to address the real situation. For that, we need a lot of data. We need average local temperature each and every region. We need the rainfall patterns of each and every region. We need the wind pattern, water movement pattern, soil movement pattern. What can be the frequency of higher intensity conditions? What can be the frequency of extreme weather conditions? All these data we need to monitor and gather. And by gathering those data, we need to do predictive modeling powered by now modern facilities are there, powered by deep data analytics. Artificial intelligence can be driven in, machine learning can be driven in, so that we can address not only the direct impacts, we can address all these indirect impacts also. Every degree matters. Now we have seen that even 1 degree centigrade, how much energy it will bring into. So each and every degree matters. We have no time to lose. The window to act is rapidly closing. Our countdown has already started. The planet is changing faster than what we expect. Now we have to decide, are we the problem and the solution? The answer is surely yes. Is the average person who is responsible? The answer is surely no. Will climate change stop if we stop emitting carbon? At least we can have a control. Are we in burn now, pay later approach? Whether our focus need to broaden up. All these questions we have to ask ourselves, and we have to find solutions, we have to find answers, and we have to start acting. Otherwise, the window will close within no time. We will be in danger within no time. With this, I conclude my presentation. Thanks for all of you for hearing me patiently. Over to you, sir.
Hello.
Hello.
Yes, sir. Thank you so much, sir, for your informative session. Now we open the floor for questions.
Yeah, can I ask a question?
Yeah,
Yes,
yes,
sir.
sir, sure.
Can I ask?
Yes, sir, you can ask.
First of all, I should thank KV Manuran sir for the wonderful case study of Los Angeles and the carbon footprint calculation, which he has in a very simple way he has shown to us. Number two is my question is number one, is this carbon footprint calculation same for every country or not? I hope I'm clear with my question.
Carbon footprint calculation?
Is it same for every country?
Same. Yes, sir. Yes, sir.
For every country.
It is same for every country. That factors are same. Depending upon their usages. Now, for our electricity generation, we are spending about 0.82 kilogram of carbon dioxide. But in USA, it is only 0.18. Their process may be more energy efficient. So, depending upon the conditions,
that means,
it will vary.
On the manufacturing activities in each country, the factors will change, but the formula is same.
Factors will change, but the cumulative projection will be same.
Okay. My second question is, we are, I think in the beginning of your talk, you were talking about the different layers of the atmosphere. So can't we think of, we're talking about climate change. Can we think of changing the climate?
That is why this climate science, we are trying to understand the natural forces that can have control over the climate. We are trying to reach that level.
No. What I mean is, see, we are having all these satellites and people going on to other planets and all those things, crossing these layers of the atmosphere. See, for everything there is a solution. I mean, see, we cannot live without all these things. I cannot live without my car driving every day. But I can only restrict maybe in a week. If I drive 7 days, I can restrict it to 2 days or 3 days, or maybe pool with my colleagues and then come to the college and go back.
Yes, sir.
So I reduce the carbon dioxide or carbon monoxide emissions. But what I'm trying to tell is, anyway, if all the people try to do this, it is fine. Totally, it will, I mean, this load will come down. But what is happening in the upper layer of the atmosphere? Is the technology, I mean, developed enough to take care of something which the climate change, what we call, that we can make the change? അങ്ങനെ വല്ലതും ഉണ്ടോ എന്നുള്ളതാണ് എനിക്കറിയേണ്ടത്.
Sooner or later we will reach that level. What sir is saying, we have to derive a control over these natural forces. Sooner or later we will reach that level. Now the storms are coming. We have the wind intensity, that monitoring stations like that, so that people can be shifted from those locations. May not be, we cannot 100% stop these effects, but we can derive methods so that the impacts are minimized.
Yeah, why I mean, after your talk, I was just thinking, because we are thinking of life on Mars planet. And Mars is a planet which doesn't have this much of oxygen and nitrogen as per what we have in our Earth, on our Earth.
Yes, sir.
But when we are planning, when we can plan such a mission, why can't we plan of changing the layer of the ozone from one point to another? Why can't we think of changing the carbon dioxide to something else in the space, and then make life better for the Earth, people who are living in the Earth? ചെയ്യാൻ പറ്റുമായിരിക്കും.
Research activities are there, sir, for carbon dioxide capture and all. But this much mammoth quantity of carbon dioxide capture, that is really a tough task. We are not yet reached that level, sir.
നമ്മൾ റീച്ച് ചെയ്തിട്ടില്ല. Okay, but just this was my thought.
Efforts are going on. That is what is called now solar is coming in wide way. That is one of the reasons to reduce this carbon dioxide emission. So such technology improvements will happen, and net zero emissions, we will be able to make it under control.
Yeah. Okay, thank you very much, sir. Thank you very much, sir, for your time and for your talk, and it was very enlightening. Personally, I'm just thanking you. I think the other coordinator, Suraj sir, will take this thing next talk. Okay.
Okay, sir. Thanks.
Thank you so much, sir. Are there any more questions from the side of the participants? You can please unmute yourself or type it in the chat box.
Sir, can you hear me, sir?
Yes, sir, I can hear, sir.
Thank you, sir, for this wonderful session. And I have one small doubt, sir.
Yes, sir.
Sir, nowadays we are always discussing about sustainable development goals and circular economy. So as you discussed these life cycle assessment principles and measures and their methods, so how we can integrate that LCA method into this common circular economy principle, sir? Up to what extent we can incorporate that?
That I have no answer, sir.
Because all are discussing about sustainable development goals now, SDG, and also discussing the circular economy principles and all these things. So LCA, that is life cycle assessments, there is a methodology right now, sir.
Yes,
so
sir.
How up to what extent, because central governments are also making so many policies and all these things. So up to what extent, sir, that is?
Sir, this our that policies and realization. And I will take one example. Now
Yes,
we
sir.
are under a plastic that carry bag that what is called a banned regime. Sir, agree?
Yes, yes, yes,
But
sir.
still it is available everywhere. So
Yes.
what we plan and act, that should be matching. Then only all these things will work. Now we are,
Yeah.
if we plan 100%, what we actually realize is like a 15% or 20%. That gap is actually doing the trouble.
Yes, sir. Yes.
I think, Suraj sir, I will answer your question
Yes,
in a
sir.
bit
Yes, sir.
more.
Yes, sir.
See,
Yes,
we
sir.
had
Yes.
a project called K-Rail.
Yes, sir.
Yes.
K-Rail,
Sir.
you're aware of that.
Yes. Yes, sir.
This K-Rail, for every project, whether it is, even if it is a tea shop, as Manjuran sir had told, we have to do a life cycle assessment.
Yes.
Hello?
Yes, sir. Yes, sir.
Yes.
Continue.
Yes, sir. It is clear, sir.
Now,
Clear, sir.
for K-Rail, there was no life cycle assessment because the problem is the regulatory authorities have to enforce LCA and life cycle analysis or life cycle assessment for any dam project which is coming in a particular area or location. അത് നടന്നിട്ടില്ല.
Sir,
അത്
all
നടന്ന്
these things
കാര്യങ്ങളെല്ലാം
are getting manipulated for personal reasons.
No, that is okay. That is the secondary part of it. But mandatory part is without an LCA. See, suppose you entrust me with an LCA, or if any project has to come, there has to be an LCA. നമ്മളിപ്പം നമ്മുടെ ഡേറ്റ് ഓഫ് ബർത്ത് കൊടുക്കുന്നതിന് SSLC സർട്ടിഫിക്കറ്റ് വേണമല്ലോ. SSLC സർട്ടിഫിക്കറ്റ് ഇല്ലാതെ ഡേറ്റ് ഓഫ് ബർത്ത് ആരെങ്കിലും ഇത് ചെയ്യുമോ? I hope
Yes,
I am
sir.
clear
Yes,
with
sir.
what എന്ന് പറഞ്ഞ് I mean with that in the context I'm telling you. So this LCA analysis has to be done for every project, whether it is a tea shop or a shop or a apartment or a mall or a railway line or whatever it is. But that is not there. You take any project in Kerala, that is not there. LCA analysis is not there. Even if it is there, it comes after the project is implemented. അതാണ് സാറ് പറഞ്ഞത് ഈ മാനിപ്പുലേറ്റഡ് എന്ന് പറഞ്ഞത്. ശരിയല്ലേ? ഹലോ?
Yes, sir. Yes, sir.
Yeah. Yes, sir. Yes, sir.
സിമ്പിൾ ആൻസർ പറഞ്ഞു, കൂടുതലൊന്നും പറയുന്നില്ല. ഇത് സൂര്യ സാർ ചോദിച്ചതിന്റെ ആൻസർ ആണ് ഞാനിപ്പോ പറഞ്ഞത്. മാഞ്ഞുരാൻ സാറ് അതിന്റെ ഒരു ആൻസർ പറഞ്ഞായിരുന്നു, അതിന്റെ ഞാൻ ആഡ് ഓൺ ചെയ്തേ ഉള്ളൂ.
Yeah.
ശരി സാർ.
Yeah. Thank you, sir. Thank you, sir. Thank you, sir.
Any more questions, sir?
Yeah, from participant side, any questions?
If no questions, then we can conclude, sir.
Yes, sir.
Okay, so yeah, I think there are no questions from the side of the participants. So I request Dr. Suraj Rajansi for delivering the thank you note to our speaker.
So thank you so much, sir,
Yes,
for
sir.
this fruitful session and detailed about the dimensions of measurability of greenhouse gases and how it would affect the climate, and detailed about the carbon footprints. And I hope that the participants received an insightful understanding about carbon footprints and dimensions of measurability of these greenhouse gases through your session, sir. And with a token of gratitude, Department of Chemical Engineering, Amaljodi College of Engineering, sharing a virtual memento to you, sir. Thank you so much, sir. Thank you so much for your valuable time over here. Thank you,
Yes,
sir.
sir. Thanks for hearing me, allowing me to participate in this seminar. And all thanks to the organizers. Thanks.
Thank you, sir. Thank you.
Okay, with that, we come to the end of our day 2 of our FDP program. So before leaving, kindly, all the participants kindly fill out the feedback form that will be shared in the chat box. It will be active only for 10 minutes. So it is essential for attendance purposes. So all participants make sure to fill the feedback form that is shared in the chat box. Thank you.